Right, I'm going to walk you through the steps for how to calculate the centroid location for a more complex shape. And so what we have here is our diagram. This is like a complex shape. This would be like the cross section. If this was like a three-dimensional structural piece, this would be the cross section of that piece. All right. And so one thing you're going to want to make sure you do is make sure you get a chart like this done, and we're going to use this chart to help us do the calculation. And so the first thing that I want to do is find the area of shape number 1. And so shape number 1 is right here. Kind of the width of that shape is 3 inches and the height is 6 inches. And so if we multiply 6 times 3, we get 18 inches squared. Okay. The next centroid shape we need to calculate is shape 2. So we need to calculate the area of this triangle. The formula is 1/2 the base times the height, so the base is 3. Divided by 2 is 1.5 times the height, and we get 4.5 inches squared for that shape. And the last one here, we have just a square. 3 times 3 equals 9, and so we have 9 inches squared. All right. The next thing we're going to calculate is from the reference line the location of the centroid of that shape from the reference line. And we're doing this in the y direction. And so this is the y direction here. So we're going from this line up and finding the centroid location. And so for shape 1, the centroid location would be at 3 inches because that gets me to the middle of that shape. For part number 2, so for shape 2, this triangular shape, I know that for a triangle, the centroid is located at 1/3 its base or 1/3 its height. And so in this case, in the y direction, we're doing the height. So it's 3 inches. So 1/3 of 3 would give me 1 inch. So the centroid is somewhere up there. So 3 plus 1, that would give me 4 inches. So to find the centroid of that triangle, again, it's 1/3 the height. So the whole height is 3. 1/3 of 3 is 1. And so 3 plus 1 equals 4 inches. For shape number 3, the centroid location is 1.5 inches in the y direction. So I'm going from this reference line to the middle of that shape is 1.5. All right, now what we do is we multiply the area times the location. And so in this case, 18 times 3, that gives me 54 inches cubed. 4.5 times 4 gives me 18 inches cubed. And 9 times 1.5 gives me 13.5 inches cubed. Okay, and now we're ready for our formula sheet. And so now that we have all the information, we can actually calculate the centroid location. So we have complex shaped centroid. We're looking at it in the y direction. And so the centroid of y, if we look straight from our formula sheet, is equal to the sum of the location times the area divided by the sum of the areas. So if I take these numbers right here and I add up 54 plus 18 plus 13 point, do that again, 54 plus 18 plus 13.5, I get 157.5 inches cubed. If I add up the areas, 18 plus 4.5 plus 9, that gives me 31.5 inches squared. So I put those numbers into my formula. 157.5 inches cubed divided by 31.5 inches squared. Divide those numbers, 157.5 divided by 31.5, I get 5 inches. So we have an inch mark left. So in the y direction, what we're saying is at 5 inches, that's the centroid location in the y direction. Here's where a little logic has to play in. So I'm looking at this, 5 inches. That would be somewhere like right here would be the center in the y direction. That doesn't make any sense. So I went back and looked at my numbers. I had a calculator error here. And so 54 plus 18 plus 13.5 is not 157.5, it's 85.5. So this is wrong and this is wrong. So if I plug in those numbers again, 85.5 divided by 31.5, I get my real answer, which is 2.714 inches, we'll call it. So that's saying if I go up 2.7 inches somewhere in here, that's the center of this shape in the y direction. And so that number makes sense for y. And so make sure, that's always a good habit to get into, is to think about what the number actually means and see if it makes sense. If it doesn't make sense, go back and figure out where you made a mistake. And so my mistake was in putting the numbers in on my calculator somewhere. Now, if we wanted to locate the true centroid of this, we'd have to do the same thing in the x direction. So we'd make another table and do from the reference line in the x direction. And if it was instead of a shape, if it was a solid, we'd have to do the same thing in the z direction. So back into my paper, and where those points would line up, that would be the geometric center of that solid. For this shape, the geometric center would be 2.7 inches up in the y direction, and we would have to calculate in the x direction how far to go over the same way. But for the sake of time, we're not going to worry about doing that for this example. And so hopefully you see how to calculate the centroid location in the y direction. It's the same for the x, but instead of x here, or instead of y here, you would have x.